students, last time we have started current electricity in live online classes. Now already yesterday I have started this concept also, that is a combination of resistors, are also called grouping of resistors. Here there are two types of combinations are there, and first one is what? First one is the series combination, okay na? And for second one is what? Parallel combination. What is the meaning of the series combination? First of all, see, you are doing some practical in the laboratory. You want some fixed value of resistance. Means what? So here you have first resistance what? For example, you have three resistance with you. What is that? R1, R2 and R3. R1 is equal to 1, R2 is equal to 2, R3 is equal to 3 resistors are there. So now you want 6 ohm resistance. But what is that? You have only 3 resistance, but these 3 are not equal to 6. Each is different. R1 is equal to 1 ohm, R2 is equal to 2 ohm, R3 is equal to 3 ohm. But you want what? A single resistor that is equal to what? 6 ohm you want. So to get the 6 ohm, how these 3 resistors are connected in the circuit? Okay, that is nothing but the combination of resistors. Okay, and first of all, in the series combination, what you want? So in the series combination, you see, first of all, I am taking the 3 resistors here. So now first resistor is R1. Here I have taken R1, and second resistance is R2. Third resistance is R3. Now here, now this is what? End of the first one. This is the second end of the first one. So now here the ends are connected to each other. Means for example, here I am taking that these are the 3 resistors are there. Now this is the first resistor, and here, and this is the second resistor, and what is that? This is the third resistance. Now if you connect them like this, now this combination is called what? That is called a series combination. In the series combination, and what is the same current passing through the each resistance is the same. How it is? Let's discuss now. You see, for example, you are taking one canal. Now here you see, so this is one canal flowing like this, water flowing like this. Okay, right now up to this water from A to B, same amount of the water is flowing. But when at the point B, if you observe, here the canal is dividing into 2 parts. Okay, some amount of the water is going like this, some amount of the water is also going like this. In the similar way, so here R1, R2, R3 are 3 resistors. These 3 resistors are connected to a single wire. Okay, now all the ends of the combination I am connecting to a battery. That battery having potential difference what? That is the voltage V. This battery supplies what? Some amount of the current. That current is what? I. Now see, this current is coming, and for example, this point you take A, and this point you take, what is that? That is B. Now, so when the current is reaching at A, so now the current passing through R1 is I. The current passing through R2 is I. The current passing through R3 is also Y. Why? Because here from this point there is no any other path. From this point there is no any other path. Means what? So from A to B there is a single path is there. Therefore, to say all the resistors are in series, same amount of the current should pass through each resistor in the series combination. That combination is nothing but what? Series combination. Therefore, now in the series combination, all resistors having the same current. Okay, that current is equal to current supplied by the battery. Now let's go here. Okay, current is the same, but what is the voltage? Voltage is the not same. Why? Because voltage depends upon the connection points. Why? Because you see, this first resistor is connected between A and this point, and the second resistor is connected between these 2 points, and the third resistance is connected between these 3 points. Therefore, now here this point is different, this point is different, this point is different. Therefore, this point is different. Therefore, now 4 points are completely different. That's why the potential difference is also different. Okay. Therefore, to say all resistors are in series combination, compulsory the current passing through the each resistor should be same. And what is that? The voltage is not same. Voltage through the first resistance is V1, voltage through the second resistance is V2, voltage through the third resistance is V3. Okay, now here I am connecting like that. So now what is the effective resistance formula? Effective resistance is equal to what? Rs is equal to R1 plus R2 plus R3 plus and so on up to Rn. Here only for convenience purpose I have connected only 3 resistance in the series combination, and this what these resistance are formula what? Rs is equal to R1 plus R2 plus, just you have to add up. Next, what is that? For identical resistance. What is the meaning of identical resistance? Here this one is R, this one is R, this is also R. Means what? All should have in the same amount of the resistance. Means what? So this is a 2 ohm, this is 2 ohm, this is also should be 2 ohm. Therefore now here if all are having the same amount of the resistance, that is called as the identical resistance. Therefore what you can get so now what is that? Rs is equal to what? Rs is equal to R plus like that. How many times? N times. So therefore N into R what? NR. Therefore you can get Rs is equal to N into R. Next, what is that here? The current supplied by the battery is how much? Or current passing through the each resistor how much? What I have given? Current through each resistor is same. Already I have told you, and what? Equal to current supplied by the battery. Okay, now what is the formula for that? Therefore, current supplied by the battery, I is equal to potential difference applied by what amount? Total resistance in the combination. Therefore, now this is what? I is equal to V by Rs is the formula. Here I have given this formula. You can observe this one. Okay. Therefore, now this is what? Current through each resistor as well as current through battery also. Means what? The amount of the current supplied by the battery is I, current passing through R1 is I, current passing through R2 is also I, current passing through R3 is equal to also what? That is I is equal to V by Rs. Next, what? So what about the voltages ratio we want? Okay, so now first of all you tell me what is that? So now the third point is what? Current ratio I1 is to I2 is to I3 is equal to what? This is the point, third point. What is that answer? Now the answer is what I told you. Current passing through R1 is equal to R2 is equal to R3. Means what? All are same. 1 is to 1 is to 1. Why? Because 1 is to 1 is to 1. Because all resistance having the same amount of the current passing through it. Next, what is the fourth point? Fourth point is that voltage ratio. What is the voltage ratio? V1 is to V2 is to and V3. Okay. For this, what is the equal to? According to Ohm's law, what is the formula for it? According to Ohm's law, voltage V is equal to what? I into R. Correct. Therefore, here what we can substitute now? Here I into R1 is to I into R2 is to I into R3. Is it? Therefore, I into R3. Here, what is the common? I cancel. What is the answer? Therefore, now R1 is to R2 is to what is that? That is the R3 I have given for this. Okay. Therefore, now the ratio of the currents what? I1 is to I2 is to I3 is equal to 1 is to 1 is to 1. And what is that? The ratio of the voltages V1 is to V2 is to V3 is equal to what? R1 is to R2 is to R3. Now, for example, for two resistance if you take, so now what I am taking here? Here I am taking two resistance system. Therefore, now for example, you see, I will take two resistance amount. What is that? So this is the first resistance and this is what? Second resistance. Only I am taking that. Okay. Now this is the battery. That battery voltage what? V. This is plus, this is minus, and you know that the battery supplies some current, and this is the R1 and this is the R2, and this is what? Voltage across the first one, and this is what? Voltage across the second one. So here, so current is the same. Current is found by what? Current formula what? I is equal to V by Rs. Then how to find out the V1 value? Therefore, voltage through the first resistance V1 is a direct formula. I am giving that R1 by R1 plus R2 into V. This is the formula for the voltage across the first resistor. Next, what is that? So now V2 is equal to what? V2 is equal to So R2 by R1 plus R2 into what? Into V. These are the very, very important formulas to simplify the problems in the combination of resistance concept. Okay, if you take third resistance, what you will get? Here if you get voltage for the third resistance, V3 is equal to what? Means what? Here I have taken only 2. Just simple. What is the answer here? You can take R3 by, so here what? R1 plus R2 plus R3 into what? Into voltage. Very, very simple formula. Okay, na? So what resistance you want to voltage, V3 is equal to R3 by total sum of all resistance, sum R1 plus R2 plus R3. Therefore now this is the small concept about what? Series combination. Here you people should think that here to say 3 resistance are in series combination, so between no other wire should be connected, or between no other any device should be connected. Means what? So here A2, for example, you take this is the A1 point, this is the A2 point. Okay, na? A1 to A2 other devices is not connected. A1 to A2 other device is not connected. A2 to AB other device is not connected. Means what? From A to B only resistors are connected. Among the gaps no other wire is connected. Then only you can say these are in series combination. For example, here one more wire you are connecting. If you take one more wire like this, if you are taking one more wire or one more resistance, now you can say this one and this 3 resistors are not in series. Why? Because here some current is coming, no I, and after coming here what? The current is dividing this side and current is going this side. Therefore now his current is divided. Therefore how much current is coming from the R1? Same current is not passing through the R2. Why? Because some current is going upside also. That is the reason. Therefore now to say resistors are in series combination, so between the resistors other wires should not be connected. This is a very, very important concept for series combination of resistors. Now let's discuss parallel combination of resistors. So what is the meaning of parallel combination? First of all, you see, first of all, I am taking 2 points. That first point let me take A, and here I am taking that second point. That point is B. Okay. First point having potential of 50 volt and the second point having a potential of 20 volt. Now what is the potential difference? Potential difference V is equal to VA minus VB, that is equal to 50 minus 20. How much? 30 volts is that. So now between these 2 points, what is the potential difference we have? 30 volt. Next, what I am doing that? So between I am taking, this is the, for example, first resistor I am connecting. That resistance name let us take, that is the R1. For this, what is the potential difference? Same, that is 30 volt. Why? Because the first terminal of resistance is connecting at point A. The second terminal of resistance is connected at point B. Therefore now both are having what? 30 volts potential difference. Therefore now between these 2 points potential difference is 30 volt, and between these 2 points we have connected the resistor. That's why the voltage across resistor is also 30 volt. Now I am taking the second resistor. What is that? So here I am taking that this is the second resistor. Therefore now what is that? That I am taking that R2. Now where this second resistor is connected, same points. What is that? So first point is A and the second point is B. Therefore now tell me, voltage across the second resistor is also what? 30 volts. Why? Because this R2 is also connected between the same 2 points. Therefore whenever you have taken many number of resistors, if they are connected between same 2 points, means what? All left terminals of the resistors should be connected at one point. All right terminals are connected should be another point, and these 2 points are connected to a battery. Such combination is called as a parallel combination. In the series combination, current is the same. Therefore, in the parallel combination, potential difference is the same. You see what is that here? This is first resistor, second resistor, third resistor. First resistor is connected at point A and it is connected at point B. Second resistor also same between A and B, and third also between A and B. Therefore, all 3 resistors are connected between A and B. Therefore, now the potential difference across R1, across R2, across R3 all are the same, that potential difference is equal to potential difference of the battery only. Okay, now let's go for this one, different types of the formulas, because these are very important for the theory derivations. Please read well those. Now what is that? In the parallel combination, what is the effective resistance? Effective resistance what? That effective resistance what? That effective resistance so is equal to what? 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. Just a reciprocal. In the series what? Rs is equal to R1 plus direct summation. But here reciprocal summation. 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. Next what? For identical resistance. What is the identical resistance? All are having the same resistance. What is that? So now 1 by Rp is equal to what? 1 by R plus 1 by R, and so on. How many times? N times. What you will get now? 1 by Rp is equal to N into 1 by R. That becomes what? N by R. But what you want? We want Rp, not 1 by Rp. Therefore, what it becomes now? Rp is equal to, take the reverse. What is that? R by N. Therefore, this is the formula for what? So, this is the formula for N identical resistance which are connected in the parallel combination. That is the formula for it. Next what? Next, so now the second point is what? So, voltage across each resistor is the same and is equal to voltage of the battery. Means what? Voltage across the first one, R1 is V. Voltage across the second one is V. Voltage across the third one is also V. Why? Because between A and B, who is there? So, battery is there. Battery voltage how much? That is the V. Therefore, in the parallel combination, voltage across the first one is equal to voltage across the second one is equal to voltage across the third one. Also, that 3 resistance voltage is equal to V only beta. But current is same? No, current is not same. Current is divided. How much? See, so now here, so this battery supplies some current. This current is coming here, coming here. After coming here, how many junctions are there? How many paths are there? 3 paths are there. In the series combination, what? Only 1 path. Right? You see, in the series combination, only 1 path is there. One way. This is one way. That's why the current is the same. But here what is that? This is not one way. It is a 3-way. Therefore now what is that? From the battery, I current is coming. After reaching the I, at the I, the current is dividing into 3 paths. What is that? So first current is I1. What is that? I1 current passing through the R1. Current passing through the R2 what? That is I2. Current passing through the R3 what? That is the I3. Therefore, currents are different in the, what is that? In this combination. Next, what is that? For the 2 resistance if you take. For the 2 resistance if you take. What is that? So now, for the 2 resistance, what is that? Current passing through the first one formula, what? I1 is equal to R2 by R1 plus R2 into what? Into I. Very, very important. You see, I1, here what I put? R2 I put. Okay. And what is the I? Current supplied by the battery. And what is that? The current through the second resistance? Current through the second resistance what? Current through the second resistance? I2 is equal to, here I1 R2. Here what will come? R1 will come. R1 by R1 plus R2 into what? Into I. Correct? Therefore now for the 2 resistance, I1 is equal to R2 by R1 plus R2 into I. I2 is equal to R1 by R1 plus R2 into I. But how to find out the I? They won't give the direct value of I. They will give only 3. What is that? So they will give the resistance of the first one, resistance of the second one, resistance of the third one, and what is that? Voltage supplied by the battery. This data only they will give. They won't give the current passing or current supplied by the battery. Therefore, what is that? So current supplied by the battery, how much current is supplied? That current I is equal to voltage by total effective resistance Rp beta. Okay, first of all, what is that? So from this 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by Rn. So you have to find out the Rp value. This Rp value you substitute in this formula. You can find out what? The current supplied by the battery. After that you substitute here. You can get the answer very easily. Therefore now this is what? This is the current through the each resistor in the given parallel combination. And these are very, very important. And let us discuss more problems on this one. Thank you.